Okay, hi everyone. Thank you for joining us today. My name is Sasha Zelanovic, and I am a product marketing manager here at Red Hat. Michael Goin and myself have been running these office hours for over a year now. We're on episode number 28. There's a lot of good stuff that we covered over the last year, and we always do record these sessions, so this one is being recorded as well. You can find them on our YouTube. I believe all of you have that link. If you don't, I think a simple, you can probably, I'll put it in a second in the Google chat here, but you can always just Google vLLM office hours YouTube, and you'll definitely get to the playlist there. And all the slides are usually linked. So Michael, I'm not sure if you have already, if you can just paste the slides here so people can follow along. So we haven't pushed a vLLM update since the last time, since 2 weeks ago. So we're not going to go into the detail there. Michael can tell me a little bit more about that when he starts talking. But we're really excited to share and to talk to you about GuideLLM, which is a tool for evaluating LLM deployments for real-world inference. We have Mark Kuritz, who is a technical staff member at Red Hat, and he's the former CTO of Neural Magic. Neural Magic is a company that was the leading contributor to the vLLM project that we all on this call, well, the people they see on the screen and me came from, and many more. We came to Red Hat in January, and now Red Hat is the leading contributor to the vLLM project. So we're really excited to share our chaps with you. And then we also have Jenny, and Jenny is, I'm really excited to have Jenny here. We've known Jenny for some time, obviously, and she has, among all the other skills, technical skills, she has amazing design background and design skills. So you're about to see, I think, one of the better presentations that you've seen during office hours. Not meaning to knock on everyone, but it's going to be a great one. So Michael, can you please go to the next slide, please? All right, so once again, welcome. We love keeping these sessions interactive. You can totally speak up if you'd like or ask questions in chat. We'll answer them in line. If the speaker is the best in the position to answer, we'll probably just wait till the end till they're done and answer them live. We are recording and live streaming the session. You can always find the recordings on YouTube. It's linked right there. You should have the slides. You can ask follow-up questions in the vLLM developer Slack. All of us are there. We also do have an office hours channel, so office-hours in the vLLM Slack. Great place to ask follow-up questions, to hear about upcoming topics, to see links and all of that good stuff. And if you can help us, again, you have the slides. If you can help forward on your social channels or with your colleagues about the live streams, we would really appreciate that. And then right before I pass it over to Michael, we love asking people where you're dialing in from. You can see all the emojis or flag emojis on the right-hand side from people that have spoken up in the past. We had a quiet period for a couple of office hours, but last time we added Chile and Colombia, which is great. So I'm hoping that we can actually add some people now. So please pull up the, hi, Michael from Boston. Please pull up Canada. Exactly. Some of you know the drill. Pull up this chat and just let us know, please, where the world you are dialing in from. Hello from New Hampshire to New Hampshire, Boston, Malaysia. Yes, I think that might be a new one. Germany, yeah, Germany is there. Wallace, welcome. You've been here so many times. From Brazil, representing Brazil, India, Canada, Chile. Nice, great having Chile twice in a row. That's great. Silly Willy. San Francisco, Orlando, Boston. Keep them coming, guys. I'll probably stop naming them right now, but again, love seeing that this is a complete global audience. So, Michael, can you please go to the next slide? All right, do you want to cover this and we can maybe share some of our adventures from last week, Michael?
Yeah, of course. Thanks, Sasha, for the warm welcome, and hello again, everybody. Yeah, as Sasha already mentioned, today we don't have a new vLLM release yet. We're working on some big optimizations for cluster scale deployment, black hole optimization that we'll hopefully cover the next time. But we are here to talk about some great vLLM community engagement we had on our sort of little roadshow in East Asia Pacific. I'm going to cover some blogs and things in the community that you should hopefully be privy to, and of course we'll have our guest speakers cover GuideLLM today.
Sweet. So, Michael, you and I and a couple of others on this call had a big trip last week. We were in Tokyo, Singapore, Michael continued on to Korea. It was all about vLLM. It was all about the community. I think my perspective was that it's amazing to see how vibrant this community is. So thank you for being part of that. We had a meetup, in-person meetup in Tokyo in our Red Hat office. There was about 200, it was a packed room, and with live stream, there was about 200 people there. One thing that I loved during that meetup is that we haven't seen at the vLLM meetup before is towards the end, we had just a bunch of random breakout sessions where people stood up and joined different microphones and screens and just talked and told us about their use cases, about their projects, and what they're working on. And it was really cool. People were eating pizza, having some drinks, and just hearing all these community members. So it wasn't just sessions. It was actually really engaging from the community side. So I really fell in love with the idea. So I would love to maybe also do something very similar during these office hours. So if somebody is willing to, speak up towards the end, perhaps, and just tell us how, how you're using vLLM or anything about your use case, we would totally love to give you that time towards the end of the call. So think about it and don't be afraid to speak up. We had a very similar thing in Singapore. It was more casual, also packed house. We booked a meetup probably 48 hours, maybe less before, and we had great drinks. It was more casual. It was great to meet the community there. And then Michael then continued on to Korea. So Michael, do you have any perspective about both Tokyo, Singapore, and then also Korea?
Yeah, I mean, definitely the level of complexity and technical knowledge that I think people have across the world in this space is really cool to see. I think in the world of open source, it's really just how much you use the software and engage with it. So it was really cool to see sort of the excitement in places where we had no idea if there was audience. And it's been great also talking to some of the other hardware accelerators in the space. Hopefully contributing and developing more hardware backends in vLLM using some of the plugin architectures that have been developed through RFCs that have developed over the weeks and months in the vLLM community. So it's just cool to see that as we try and define standards in a big project like vLLM, seeing that trickle down and be used and useful for software, model deployment, hardware companies. It just really kind of drives forward that it's good to be careful and meaningful with the work we do here and try to set good standards to keep open source AI healthy.
That's awesome. Thank you for saying that, Michael. And I just realized that Charles from Model Labs joined us. Charles, I might put you on the spot. I was saying earlier that we want to use these office hours to give a platform for everybody in the community to share some cool things they're working on. We know you're working on some cool stuff, and it's really relatable to GuideLLM. So maybe after the session, if you're still here, you can give us a minute or two long spiel about some of the stuff you've been working on. So I'll pass it over to you.
Ready to talk about open LLM inference at any moment, Sasha.
Nice.
So, yeah.
Nice.
Yeah,
I love
all off the cuff is appreciated.
Yeah, totally love it. All right, guys.
Yeah, let's kick off and get started on the introduction stuff. So obviously, if you're not familiar with vLLM already, it's the fastest growing standard in open source model serving. Of course, well over 50,000 stars now. It's a Apache 2.0 project on GitHub, several other projects underneath the vLLM project as well. Under the PyTorch Foundation, it's a pip install or a Docker image away, heavily Python-based library with easy-to-use CLI and Python-based integrations. Yeah, you can see some of the stats here. Over 1,000, I think now over 1,200 unique contributors and many different companies contributing and sponsoring the project. It, of course, supports all the state-of-the-art models of the day and many different hardware backends, which even some that aren't labeled here. And so, like, the reason why vLLM has become so popular is because it's fast and easy to use. It supports 100+ different model architectures, regularly, inference acceleration and ML systems research is built on top of vLLM and forks of vLLM, and these papers and forks regularly get folded back in to the open source community in vLLM. And through all the different software interfaces and software ideas and algorithms that vLLM defines, this makes for a very convenient abstraction layer that the many different hardware accelerator backends for running machine learning models can plug into and integrate. So of course, vLLM strives for great performance on NVIDIA GPUs, but also has really, good support for AMD GPUs, Google TPUs, backends for AWS Neuron, Intel accelerators, Huawei accelerators, and even CPUs. And then, of course, with the hardware and model support, it doesn't just support text-only large language models. It also supports multimodal models, not just global self-attention transformers, but also hybrid attention models like Mamba and ones that use state space models. Also, not just autoregressive LLMs, but embedding models, encoder only, encoder decoders. And it can be used in RLHF pipelines. It is integrated with like TRL and OpenRLHF and vRL libraries for doing inference rollout for GRPO. It of course, supports many different optimizations there, and many different types of quantization that we've worked a lot on. So making use of those nice tensor cores that you have available in lower precisions like FP8 and now FP4. And of course, many different custom kernels, both integrated from external libraries like Flash Infer and Flash Attention, and also custom ones that we've developed within the project using Cutlass, Triton, and of course, now that vLLM is under the Torch Foundation, a really good reliance on Torch Compile that we hope to grow over time to make it so we need less custom kernels in the project. And then also, outside of making the inference of the models themselves faster, also making the scheduling and use of each forward pass more efficient through implementing like chunked prefill or multi-LoRa batching, various speculative decoding methods, supporting disaggregated prefill for distributed inference. And then, of course, various application level features like tool and function calling, structured outputs, various sampling features, and then to scale your model deployments beyond single device hardware accelerators. So using tensor, pipeline, expert, data parallelism, and also disaggregating prefill and decode. So you can start to deploy your models across multiple devices and even multiple hosts as we scale up to large models. And then a little bit about like why is Red Hat here talking about vLLM. We work a lot on vLLM. We're a top contributor to it and help shepherd a lot of the work that happens in there. And yeah, particularly on a lot of the inference acceleration, Torch Compile integration, reducing system overhead, and defining various features and RFCs in the project. We're really happy to contribute heavily to the project, both inside and outside of vLLM. So yeah, say hi if you see us on GitHub. That's for the introduction to vLLM. In terms of new blogs that we have, there have been some new blogs on related projects like LLM Compressor under the vLLM project. We released a sort of joint blog with the Axolotl project, which is a really cool training library. Essentially, the integration here with LLM Compressor is to enable sparse fine-tuning of models, sparse transfer learning. So taking some 2.4 sparse models that we've produced from our research lab at Red Hat AI, and allowing this to be efficiently fine-tuned within Axolotl. And then we hope to also, expand this into doing better quantization-aware training with combining between Axolotl and LLM Compressor to hopefully get even better accuracy recovery than we get from just post-training calibration when doing quantization in LLM Compressor. So give that blog a try if you're interested in training with compression. And then there's been a blog on GuideLLM, but hopefully you don't really need to read that if you stay here and watch the presentation. And another blog on some of the enterprise cost of hosting large language models. And then some more things in the community. There was an update from the LMD community update for this month, June. There's a survey where they're interested to learn about your use cases and what you'd like to see from the project. If you're not familiar, LMD is a distributed inference project, Kubernetes native, built on top of vLLM, and they're doing a lot of good work, making various special interest group meetings that you can join and comment in, and making all those recordings public. And they have their own Slack channel and project calendar. So if you're interested in scaling your deployments of vLLM in the Kubernetes native way, definitely check out their community update and how that's growing. And that's really all I had to cover here. So without further ado, I'll hand it off to Jenny to take us through GuideLLM. Mark. Nice. Okay. Take it away.
All right. I'm going to confirm everybody can hear me, which seems like it's the deal. All right. Welcome and thank you, Michael, for that introduction. My name is Jenny, and I'll let Mark introduce himself as well. But we're just to begin with, we're really, really excited to present this to you in this session. I used to be an audience here, and I pushed Michael and Sasha that we got to get our GuideLLM here. So our goal here is to convince you to try it, use it, find opportunities to expand on it. And please ask any of your questions on the chat, and I'm sure we'll get to the questions. And yeah, I'm a product manager at Red Hat, but I actually was a designer at Neuromagic, which you may have seen me do, like the green door office hour thumbnail. That was from me. And anyway, I'm really excited to be here, and I'll hand it off to Mark.
Hey Jenny, hi everyone. Like Jenny, I am from Neuromagic as well. I was the CTO there, so focus on research and engineering strategy, things like that. And now under the CTO arm at Red Hat, pretty much doing the same focus areas. So really excited to present with everyone. And just echoing Jenny, please, we would love contributors and users and things like that. So definitely go check out the repo.
Okay, great. So agenda today, we'll walk over kind of the problem that we're trying to solve with GuideLLM, and then we'll go through examples of how to configure a real-world workload, and then how do you analyze the benchmarks that GuideLLM presents, and then the architecture of how it works under the hood, and then what's next? What can you do to build on top of it? So 2024 was a year of experimentation for LLMs, and these are from our conversation with Red Hat customers, Neuromagic customers. And 2025, as we see it, after doing Red Hat Summit and IBM Think, 2025 is a year of production deployment. As you can see with the LLMD, we are seeing more and more customers have use cases like RAG, chatbots, and code assistants that are in production. So as these LLM applications are integrated more into an enterprise core workflow and user-facing products, we see a demand for betting-performing models. We see a demand for customized models, especially optimized for quality responses and infrastructure cost control. So as we enter this new phase of LLM adoption, we want to make sure that these Gen AI experiences are not just about capabilities, they're not just about functionalities, but it's also giving you quality responses, and it's also scalable on your cluster. So this shift is pretty massive. We see Gartner project $644 billion in AI spending in 2025. It just reflects how strategic these technologies have become.
Right. Awesome. So all of that kind of sets up for the inference problem and mainly the common pain points that go into that, especially as we look at moving into deployments and especially production-ready deployments. So ultimately, we're usually balancing between three things, and generally can only pick two out of the three, and we're going to be hurt on one. So to give some examples, we're always balancing between accuracy, performance, and costs. So high accuracy, meaning a large model, things like that. And to be able to get low latency, it's going to take a lot of cost because we need a lot of infrastructure to be able to serve that. Going on another pathway, we can pick low cost and high accuracy. right? So we keep the big model, but we try and constrain the infrastructure, and that means that we're going to have high latency and overall potentially hurt our application and the user experience there. And finally, we can pick low cost and low latency, where we're scaling the model down and we can respond quickly, but that generally means that we're going to have to sacrifice on accuracy. So all of this sets up for, choosing the right model, performance targets, hardware. It's all very complex, and there's not really clear measurements out there. So it's hard to make informed decisions. So what we look into next, though, is, how can we start framing this and breaking this problem down a little bit more? The first part is generally going to be choosing the right model and hardware setup, but that is a really massive search space, right? There's a lot of different hardwares out there and significantly more models that we can pick from, and we have no idea generally, which one's going to be the most accurate for our specific use case, but also which one's going to be accurate enough and performant enough. That's what we mean by actually usable. So service level objectives are generally the pathway that enterprises will go down to try and define what are our constraints that we want to define for our users, so that we know that we're responding to them fast enough, so our application remains responsive enough for day-to-day use, and also trying to be accurate within that. And once defined, what that does for those SLOs is it significantly constrains that optimization space, so that we can try and pick these combinations, but ultimately we can pick these combinations that will allow us to optimize for the lowest cost while meeting those SLOs. And then finally, just talking through, or actually two more points. One is from priorities to precision. So the big thing is when we're looking at LLMs and LLM inference execution, there are stages to that. Right, and prefill versus decode, where prefill we're computing all the tokens at once for our prompt and generating one token, and then decode as we iteratively or auto-regressively generate more and more tokens. Those have different compute profiles. Prefill is generally more compute bound, decode is more memory bound, and also the token lengths can definitely significantly affect our latencies that we're looking at there and overall performance. So what that means is using unrealistic token distributions can definitely skew those performance and cost estimates, right? If we're putting in the wrong number of tokens for our prompt, maybe we're underestimating and getting much smaller latencies than what we would actually get from our real world users. But also real data within those, specifically the token distributions and mimicking what our users will be putting in, can impact that significantly if we don't do that. And this is specifically because of a lot of the modern LLM serving techniques, a lot obviously available in vLLM, and now coming in LLMD from the recent, or the earlier mention from Michael, where we have things like structure generation and speculative decoding, which absolutely depend on trying to predict that next token to be able to increase inference performance, but also prefix caching, right? So being able to say across multiple requests, we have a standard template, or we expect these users, this set of users, to put in this start to the request. And then finally, session caching, right? Being able to move KV cache around to be able to be most optimized as we start scaling across multiple servers.
So GuideLLM is what we built to solve these challenges in order to evaluate and optimize for your LLM deployments for real-world inference. That's a mouthful. Here's kind of screenshots from how the experience work. The left is on the console experience. The top right is the data that's generated that we use to visualize our graphs from Neuromagic research team. And the bottom right is the most recent UI that is almost being merged and almost able to be used by you. But so here are the three really true things that we want to target. We want to be able to compare model variants to find the best fit for your application. We want to be able to understand how hardware and scaling impact latency and cost. And we want to set realistic performance SLOs based on real-world benchmarks for your data. So at GuideLLM, we're here to focus on flexibility and optionality when it comes to configuring what is the simulated workload. We want to make it easy to understand performance limits and how it impacts the trade-off between cost, latency, and quality. So here's a diagram of what the user flow is. So you would go with model selection first. You select a model. You can fine tune it, compress it using LLM compressor. Then you would choose a data set or you can create a data from the synthetic data generation in GuideLLM. That basically is your workload profile in terms of, if it's chat, how many tokens is in prompt and output. If it's another application, what would the data set be? And then we'll run it on your hardware. On your hardware, it'll hit an API endpoint from vLLM, and GuideLLM, after hitting that, will give you a guidance report on what are the metrics, what are latent metrics that you can foresee in this workload. And if it passes your desired SLO, then you can deploy it on vLLM. So high-level use cases that come from this user flow could include, you could use GuideLLM pre-deployment. It helps you select models, maybe a model size within the family. It can also help you with cost and capacity planning as you get a maximum RPS from this single server that we're benchmarking. It can inform you in horizontal scaling, and that's how we can see how it relates to capacity planning. You can also do regression and A/B testing. So if you have changed the model, updated the model, or you see any performance alerts or issues, then you can use GuideLLM to help debug that and to see what are the changes to your latency from that model change. And lastly, you can compare different hardwares, just running multiple benchmarks, and you can see which one is the best fit for your application.
Awesome. So let's dive in now into what it looks like for GuideLLM using it and simulating a real-world workload. First, just kind of framing it. Let's start up our vLLM server. So we can spin that up on either the same node that we're running GuideLLM on or on a different node and using HTTP requests there. Or you might have a really advanced use case where you are trying to measure orchestrated systems, and you have an entire load balancer in front of it with multiple instances of vLLM. All of that fully supported. And once we're able to spin that up and have vLLM actively running, now we're essentially set up for GuideLLM to be able to measure. And GuideLLM specifically is set up right now to target OpenAI compatible HTTP servers. And so it'll work against any of those. So it allows you to also be able to compare and see how performant individual servers and inference software is. So we then kick off a GuideLLM run. And what it's going to measure is it's going to send a bunch of different requests given different data distributions that you define, as well as different rates that you're defining to hit it at. We'll go through that in a lot more detail later. But ultimately, what it's going to capture are the statistics around what you want to look at for those SLOs, as well as how you're going to be able to figure out cost optimization. So performance metrics, where we're looking at requests per second, that's our throughput measurement. And ultimately, we're trying to figure out for each server, what's the maximum requests per second that we can hit with our configuration while meeting our user SLOs. So for those SLOs, generally we'll define those around latencies, either request latency, where we're looking at the entire time to get back to the user and complete the generation request, or time to first token. This is going to be the total prefill time and the first token that we get back, so request sent and then the first token coming back. Inter-token latency, which is then looking at the time between each token generated after we get that first token, or time per output token, which essentially combines both TTFT and ITL together. And ultimately, all of that's going to come together into a lot of different statistical summaries. Because everything in the real world is not exact, we're going to definitely have different distributions, especially as we have different request rates hitting it and varying. So all of this is going to return back some statistical summaries so we can make some informed decisions against those. Diving into the workload types and specifically the request rates that we might want to hit it with, these are all the different pathways that GuideLLM can support. The first one is sweep, which is just going to run a combination of the other ones. This is essentially an automated pathway where it'll figure out what the best absolute performance you can expect while maximizing the server. So it's a synchronous use case. Synchronous being where we're going to run a single stream of requests, acting like a single user, hitting the server as fast as possible. And then it's going to run a throughput benchmark where it's going to try and send all requests at once. And that's going to figure out our maximum bound of where does a server start falling behind on performance. So therefore, what's the maximum RPS that that server model can handle. Once we can figure out the minimum maximum bounds, then we're going to run a series of benchmarks in between around an asynchronous use case. So that can either be constant or Poisson. Constant being where we're sending requests at a constant rate. So this can be 5 requests per second. It's going to equally intersperse those and consistently send those out. Poisson is a distribution where we're essentially sampling from a Poisson distribution to decide how often and when we should send those requests. It always tries to target the mean rate that the user's putting in, but it can vary around that, and it's a little bit better towards simulating real-world use cases. And then finally, concurrent, if you care about the maximum number of concurrent users that you can handle at once, then this will be a great use case to go through where you can define 10 different users and say that they're all hitting that server at once as fast as possible. Then you can define that and ultimately be able to figure out how those SLOs are changing, either based on RPS or based on concurrency. Next, we have datasets as the other input to bring in, and this is towards the earlier point of we want to make sure that the data that we're hitting the server model with are representative of what we're going to see as we deploy this application. So GuideLLM supports a number of different datasets to ensure that you can ideally mimic that distribution. It supports Hugging Face datasets. You can just put in any Hugging Face dataset ID on there. Generally, it will work with all of those. It'll also take in file-based datasets, so CSVs, JSON-L files, things like that. And in-memory datasets, if you're using the Python API pathways, you can just pass in a list of prompts you want to send, and it'll start running with those. The final one, which is kind of the biggest use case, at least towards simulating and matching your expected distributions, is going to be synthetic data. And that's where you just describe what the distribution looks like for prompt tokens, which can vary across a wide range, as well as how many output tokens are expected and the statistical distribution that should match. And it's going to create a bunch of different requests and different data so that it can match that exact setup that you're looking at. Okay, so now we dive into what this looks like after we're able to kick off that benchmark. So in this case, we're looking at a chat use case for a Llama 3.1 8B model. In this case, it is quantized. And ultimately, we want to figure out what's the maximum RPS we can hit for the GPU we're running on. In this case, we define it as an L40 while meeting our SLOs. The SLO that we're going to define for this is such that our time to first token is less than 200 milliseconds for 99% of our users or traffic that we're seeing. So we use the GuideLLM benchmark command as shown there, where we're going to tell it the target. We're just telling it where the OpenAI server is running. We're going to tell it to run the sweep, which will run that full range of RPS across it. And then we're just giving it a little bit of constraints to say that for each benchmark, we're going to run that benchmark for 30 seconds to make sure we get a good measurement. And then finally, our data, we're defining as 512 prompt tokens and 256 output tokens, just to give an example. Generally, you'll want to give a different distribution here, add or standard deviation, things like that. But this will be our simple example.
Okay, so after you run that, how do you analyze, interpret the results? So let's take the chat example that we set up earlier, and let's run a benchmark. While generating, you will see a preview of the time and the generation time and when it'll finish. Then when you see the console output, it'll be separated in 3 sections. Number 1 is the overall metadata that you've inputted, just to be able to track what benchmarks and arguments that you ran it with. The second section is on metadata per benchmark and per rate type. And then lastly is the most important part is the comprehensive benchmark statistics, which include all of the latency benchmarks and also the percentiles and the summary statistics for all. So taking our use case earlier on the chat, Our target SLO is for the TTFT to be less than 200 milliseconds for 99% of requests. That's a very strict SLO, but here we are. But the table basically shows us it's about 10.69 RPS that can match this. So this test gives us an empirical per node RPS limit for staying within our SLO, which you can then take and have a naive prediction of what the horizontal scaling is for your in production. Now it's pretty troublesome to do all this on a console, and that's why we have multiple different outputs for you to use. So yeah, if you can look at a console for the quick results, then we have JSON, YAML, CSV, NHTML outputs for if you want to take it and visualize your own, which Charles have, I think, with his amazing blog. And lastly, we have a UI that we're still working on, but we can preview for you today. So CSV, we've been using this output to create ML research from Neuromagic blogs that you've seen here. And for the UI, okay, I'm assuming this is being shared. So okay, perfect. So they'll generate a workflow report, and we created this UI because we realized, visualizing and not seeing the actual results is difficult. So in the workflow report, it follows a similar structure to the console. You'll first see all the metadata that goes in, what model was hitting. This is not exactly our use case. What time was it executed on? Here you'll see the prompt and generated token, and if you follow the distribution that you've asked. In the middle, you'll see here kind of visualizing the rate type that you chose, and this is a sweep. So this makes sense in that you do the min and the max, and then you do increments of constants. And then this is a component for visualizing how your service level objectives, which you can enter here, how does it match up against the actual real-time data? So on this slider, it graphs every single TTFT, TPOT, time per request, and throughput, which are the 4 key metrics that we think are important. And you can see at what point are all SLOs satisfied. And for here, in this run, it was 16.18 RPS if we set the SLO here. So this is a pretty fun gadget to play around with the data. And these are kind of the details we want to dive in the percentiles on each metric and how they performed.
Okay, great. So let's dive into a little bit more on the underlying pieces on how we can trust these results. There's some questions going on in the messages, and I think this will help clear up, especially the difference between what GuideLLM, how GuideLLM is set up, and where it differs from the vLLM benchmarking script. So the first part is really looking at, can we ensure accurate scheduling at any scale, right? So this is designed to ensure that we can scale up from the smallest use cases up to multi-server nodes and still be accurate with our load generation and request generation. All of that built around first Python, so that it is compatible with popular data sets and pipelines like Hugging Face transformers and data sets, as well as standard ML orchestration technologies. But within that, obviously with Python, we can take on some performance hits because of that. So GuideLLM is set up explicitly to try and avoid those. What it does is it creates a hybrid multiprocessing and multi-threading setup. Multiprocessing so we can get around the GIL, as well as async IO bottlenecks towards it using only one core. And then multi-threading specifically there so that we can use async IO and ideally optimally use the compute available on the node that we're running our benchmark from for those IO bound tasks, right? We're running a lot of IO bound tasks, either from loading the data to run the request with, and especially for the actual HTTP requests that we're sending over. And ultimately, this has been tested up to 1,000 RPS from a single node. We are looking to increase that. We'll go through, how we're doing that a little bit later. But also within that constraint, it's been measured and consistently measured to be 99.9% accurate to the scheduled start request times. So we can guarantee that whatever distribution you put in to try and match, it is going to very accurately match that much more accurately than a lot of the other benchmarking solutions out there. And then also it has significantly less overheads within those pipelines, primarily because of that multiprocessing, multi-threading, to the point that whenever we're running concurrent or synchronous pipelines, where, as soon as we receive the request, then we need to send the next request as fast as possible, it's only 0.2% overhead. So if we're targeting 5 concurrent users, it's going to come out somewhere around 4.98 or 4.8 or 4.9 for that concurrency towards getting as accurate as possible. The next piece then is also how the metrics are measured. And so big piece is that we aren't sampling any of the data ever underneath the under the hood. And with that, we're actually generating full probability and cumulative distribution functions so that we can actually map out many more statistics than what you traditionally would have available, as well as on things like throughput measurements of output tokens per second or total tokens per second, where generally you wouldn't have a distribution because you're just averaging over that. So that allows us to be able to also see variance in, the output tokens per second, total throughput measurements. So with those distribution functions, like I said, we're calculating mean, median, mode, variance, all the different percentiles you could want, and a lot more alongside that. And finally, if you would like, you can keep all of the request details and store those out in case you do want to dive in and map out some other statistics that aren't built in. And then the final piece to run through for the section is the auditable and transparent benchmarking. So this is where we're looking at making sure that we have deterministic pathways where if we rerun these benchmarks, we are going to get at least the same load generation that happens and the same request rate that happens so that we can reproduce these environments and also ensure as we're comparing across configurations that our the load generation and the requests that we're sending match. And that's really important so that we're not measuring noise as we go to these comparisons. On top of that, every pathway within GuideLLM has built-in performance timing and measurements to ensure accurate system tracking. So this is where we're looking at timings for what was the target start time versus the actual start, any scheduling overheads that are happening, any HTTP request overheads that are happening, and things like that. All of that's optional, so you can display it live in the terminal through the UI that Jenny just ran through. And also all that aggregate information is always stored with the reports that are output. So you can always, if you have this in orchestration system, you always have that data available so you can go back and see if there was an issue that might have happened. All right. And next, let's dive into how you could go about expanding GuideLLM. This is the rough overall architecture that we're looking at. So on the left, we have a dataset creator and scheduling strategy that's going to come in. The dataset creator is going to create that number of datasets that we went through before, hand off a Hugging Face dataset to our request loader. The request loader is just generating or creating the requests that need to be sent out. And then we have a scheduling strategy, which is going to tell us how we need to generate the times for the request to be sent. All of that goes into a scheduler, and the scheduler is where it's doing the multiprocessing and multi-threading. So it's breaking this across multiple workers with a shared queue to ensure that we're sending those requests as fast as needed. After each benchmark runs, the benchmarker is actually what's controlling that. So it's handling creating a scheduler, running it to completion for that individual benchmark that you want, and then being able to aggregate all of those results. That's the pathway that you see on the bottom there, and then outputting those benchmark results. The only other pathway that I didn't talk through is at the top, where each request worker that's spun up from that scheduler is hitting a generic backend interface so it's extensible. And we'll run through that next. So there was a question also in the chat towards, where can I use it? And specifically if there's a Python API available. Yes, definitely. GuideLLM supports both CLI and Python APIs. Ultimately, just trying to ensure that you can enable it wherever you need it, including notebooks, scripts, CI, pipelines, orchestration systems, things like that. And within those CLI and APIs, there's one-to-one compatibility with all the features and arguments. So you're not giving up one way or the other for different things that you can do. And all of the Python entry points, additionally, are broken down into modular stages. So you can actually go and construct your own entry point if you'd like, and be able to pull those in individually. And ultimately, what that sets up for is ideally minimal setup required. So you can just install it, import it wherever you need, and then start running. And towards that point on the backends and that architecture, ultimately, GuideLLM was designed to be modular, right? There's a lot of complications or complexities that can go into a multiprocessing system. People that are working on vLLM definitely know that as well with the V1 project and things like that. But diving into each of these pieces, so the data pathways, you can extend and create your own data pathways by creating your own dataset creator. That's going to output a Hugging Face dataset that can be used throughout the rest of the pipeline. You can also create your own custom requests generator and plug that in as well. It'll support that. You can create new scheduling strategy or profile classes. Scheduling strategy is things like the synchronous or concurrent use cases. That's just telling it what times to schedule everything at. And then the profile is what controls the scheduling strategy. So that's what complicated pathways like sweep is doing. So it's telling it to run the throughput scheduling strategy and the synchronous scheduling strategy, and then calculating the rest to run in between. Additionally, you can customize that backend interface that we just ran through for benchmarking any GenAI pathway. Currently supports OpenAI HTTP, as we talked over, but definitely want as many contributions as we can. If there's something that you would love to see benchmarked, it should be pretty straightforward to be able to plug into that. And you don't need to change anything else as this is going through for the scheduler or benchmarker. And additionally, all of the requests and result objects built on top of Pydantic, so that there's good base support towards documentation and serialization.
So what's next? So everything that Mark said on how to use it beyond the CLI. We're Python native. You can import these core modules and call these benchmark functions directly. You can compose scripts and pipelines for your custom workflows, for the use case that we mentioned in the beginning, notebooks and integrations. And GuideLLM is open source. Please try it, file a feature request or an issue, and add everything that Mark was talking about earlier. And give us a star too. We're on our track to become a big repo. Who's using it? So right now we have internal adoption as us, or had as customer 0. We want to try our tools before we release it to the world. So Red Hat AI model validation program, any model that you see in Red Hat AI that's validated, it uses GuideLLM as a way to test and benchmark. And we give these data to our customers for them to have guidance on model selection and for troubleshooting performances. Prior to Red Hat, all of Neuromagic's blogs are also created by GuideLLM. And then also want to shout out again Charles Fry on this amazing blog that also visualizes the benchmarks and all the configurations you can put into a benchmark. Definitely check that out. It's a really beautifully designed website as well. So these are our future roadmap is how we have planned it. If you go to GitHub, you'll see the current PRs and issues that are up. But we're looking forward to supporting complex use cases like multi-turn chat and for multimodal inputs in image and audio, so we can start benchmarking with models like Whisper. We also want a automatic saturation detection to identify performance limits and stabilize benchmarks. That just helps with the usability of GuideLLM itself. We also want to, this is part of our wish list, to build in accuracy evaluations. And as you heard, SLOs are not just latency, it's also accuracy. So we're hoping to build that into this GuideLLM flow as well, so it can be a pre-deployment tool and not just for latency. Other things that are on the wish list, a Python backend support for native integration of vLLM, standardized deployment scenarios, again, towards that usability, and distributed benchmarking support across nodes and clusters so that we can help distributed workloads like in LLMD in understanding how models perform there. All right, that was the end of our presentation, but I just wanted to give a shout out to, we're not just me and Mark, we have a team at Red Hat that works on this, and the people that you see talking in the messages, Sam, I saw him there, so there's plenty of people who are working on it from Red Hat, but again, we've loved for more contributors. Thank you.
Yeah, thanks a lot for the great presentation, and there's been a lively discussion, I think, along the way. Yeah, maybe we could just dive into some of the questions in the chat. Otherwise, feel free to come off mute and ask face to face. Side note, I love all the the otters in chat. I hope they're confident with their sexuality.
I think just just kind of repeating the ones that that have gone through chat that we've been answering. Sorry, trying to scroll through all of the otter notes. Let's see.
There's a question on linking scheduling strategy with a third-party application. Do you mean by like a plugin style without needing upstream integration? Malik? Maybe. Yes. Yeah. So, Mark, can you?
Yeah, at least for the scheduling strategy, you can definitely implement your own. The base of it is just returning a generator that's going to return the times to schedule at. To be able to use that, you'll need to use a scheduler, the base scheduler. The inputs to the base scheduler are going to be the backend to use, the scheduling strategy to use, and then the data, essentially the generator for the requests to send to the backend. So provided you integrate that into whatever plugin you want, that's kind of the base core that you would need. And then you can definitely stack more on top of that if you would like, all the way up to the benchmarker or the Python entry point. Not sure if I answered it exactly, but yeah, that's how I understood it. Another question came in. Suppose we want a new metric, for example, power consumed for tokens generated. I'll assume we can do that. That's yeah, definitely can plug it in. You'll need to extend the metric classes that we have to be able to push those. We do have some plans in the future to try and get exact cost analysis and things like that, and potentially energy analysis with that. But yeah, it's a little bit more of a core change to be able to actively calculate that and things like that. It's not a base interface, but definitely welcome contributions around that to do that.
We have a few hands raised too, so let's go to those and we'll come back to the chat. So Sanjeev, you raised it first. Do you want to ask a question?
Yeah, are there good tools available to assist people that are, providing their own data to generate the best set of testing prompts that will exercise their customization? Otherwise, it's, the tests benchmarks may be only as good as the kinds of data set questions that are asked, and it's not obvious whether they will always be the right data set. So I assume this is out of scope of GuideLLM, but maybe there are some pointers.
I'm trying to think if I know anything off the top of my head. This is, I mean, kind of separately within GuideLLM, this is definitely a direction that we're trying to add in, which is we just landed something called scenarios, which essentially pre-encodes the distributions and also the data sets to use, things like that. Towards your point of at least 4 standard use cases, we'll have a good representation, and this is sampled. All of these are intended to be sampled from the average on Hugging Face, essentially, to be able to target these different scenarios, as well as we're trying to get some input from enterprises for SLOs to set and things like that. So that definitely is getting added in, at least for immediate support. I think that's going to be a little bit of digging into, I think the prefill, the disaggregated prefill paper, if you look up that one has some reasonable setups for different data distributions and specifically the SLOs that go with that. to use for different use cases. The other one would be, we actually, at Red Hat, we had pushed out a paper around, it's called Give Me BF16 or Give Me Death is the start of it. If you look for that on archive, that has a ton of information around the different data distributions that you want to run and things like that we actively measured. This one was focused on is quantization hurting accuracy around those. So those would be the immediate resources. Otherwise, probably diving into some Hugging Face Transformer docs and things like that. I don't know if Michael or anybody else knows of anything off the top of their head.
Ford, do you want to go ahead?
I guess let me just requalify that question. Let's say that you're doing, you're targeting how your model performs on large context RAG.
Mm-hmm.
You may have some idea of what context you will populate, but you may not.
Mm-hmm.
Or you may have, just a rough idea. So how would you define questions in your data set that allow for, this RAG augmentation to be properly tested?
Gotcha. I have not seen anything that's automated towards that. Mainly what I've seen is companies already, or users already have some subset of example data that they're going to use and run with. There might be pathways through synthetic data generation pathways and tooling around that given a few prompts or examples, then you can tell it to expand out. You can also include kind of the context database to figure out new questions. This is somewhat akin to what InstructLab does from Red Hat. So you potentially could use that pathway.
Thanks.
Yeah, so following up on that, so you can search up InstructLab/SDG. That's where you can, giving 5 samples of a specific data, you can generate more that is similar to the data that you fed it. So definitely look at that in terms of how to answer this question.
I'll put the link in the chat right now. While I'm doing that, Ford, you go ahead.
Hey, everybody. Thank you for the presentation, Jenny and Mark, and thanks for all the work on this. Super exciting. I wanted to ask about the multi-turn conversation benchmark element. I have been working a lot with KV caching and external KV caching, LM Cache, Mooncake, AI Bricks, maybe one day Dynamo. And there's not really something, certainly not an industry standard, hardly really anything at all for measuring KV cache hit rates and multi-turn conversations to, with different hit rates and different amounts of KV cache storage, KV cache hits from different tiers of KV cache storage, all of that. Complicated topic, but curious how much you're thinking about that in the multi-turn benchmark, if that's within scope or out of what you're thinking about for GuideLLM.
Yeah, at least for the immediate short term, for the first implementation on multi-turn, we're not looking at trying to surface the exact KV cache hit rate underneath and getting access to the processes, things like that. It's something that we want to do in the future and add in. But there's also a little bit of who that should belong to, whether that should belong to the orchestration system or if that should belong to the load generation and benchmarking platform. So there's a little bit of difference there. But at least for the immediate multi-turn, we're definitely trying to go out and define and give an industry standard, or at least an opinion of an industry standard for what those data pipelines would look. And the byproduct of that would be measuring your request latencies and your throughput to see how that's shifting based on an assumed KV cache hit rate that has to happen under the hood. So no direct measurement, but indirect measurement for the start. And then hopefully we can get more direct measurements later on.
Thanks, Mark. And if anybody else has comments or answers to any of these questions, just put them in chat or speak up, please. In the meantime, Charles, go ahead, please.
Huge fan, big users of GuideLLM, and found it like we were doing a bunch of benchmarking ourselves, and it would take like weeks to do a benchmark for a customer and feel confident we got good numbers. And now I recently did a benchmark on a plane in 15 minutes. So like major gratitude to the team for shipping something that increases everybody's productivity so much. I am curious. We ran into a little bit of trouble with structured output generation benchmarking. It's kind of like what a natural thing to do is set like an output length, and then structured generation fails. I'm curious what your thoughts are on like how to appropriately do structured output benchmarking. Maybe it's just embrace the variability of output lengths. Maybe it's just like find the right task or something else.
Yeah, I think at least for what's built into GuideLLM right now, I would definitely recommend going through either a collected data set or a target Hugging Face data set. It's going to be the most accurate pathway, but obviously you do have a lot of variability if you're trying to target exact token lengths. It gets a little bit trickier. This is something that's on kind of the medium-term roadmap, which is for the synthetic data pathways, be able to generate something that's going to be more usable for specific use cases like structured generation or code generation, things like that. So right now, unfortunately, need to use real data, I would say. And then hopefully in the medium term, we'll be able to land something that you'll be able to plug in a specific source for the synthetic data set or a target for the synthetic data set.
Yeah, I can say a little bit, because on the structured output side within the benchmark scripts we've like experimented with inside of vLLM, it's a really hard thing to hold for, and it's like apples and oranges if you're trying to benchmark like doing a data set without structured outputs enabled versus some ratio of structured outputs enabled. We did this while we were optimizing structured output support in vLLM to try and see not like regressions in performance if structured outputs are enabled, but yeah, you just don't get the same like output tokens because at some point the model stops. We mask off all the logits because we don't have anything valid more to produce. So yeah, it's tough to do in a general case. I think you can do some synthetic ways of forcing that, but yeah, it's definitely a research question.
Got it.
Thanks for jumping.
And then,
Charles?
yeah, sorry, my audio is cutting out a little bit. At the exact moment I wanted to do something slightly rude, and just like a comment from my experience with using this tool and doing a lot of LLM benchmarking, is you want to be really careful to like separate concerns ahead of time before you start doing your benchmarking. Like on our platform, there's auto scaling. You got to benchmark with auto scaling turned off first. You've got structured outputs, or you've got LoRa's, or you've got you've got concerns about like quality and accuracy. You've got concerns about whether it's exact matches to your data set. You really want to separate those concerns out when you're doing this like synthetic, like outside of prod benchmarking. And then when it comes to like putting all that stuff together, you just gotta monitor what's happening in production. And that'll give you the like actual thing that you care about, rather than trying to replicate it perfectly in testing. So that's my 10 cents from a few $1,000s of LLM benchmarking.
I think that's a great summary, which is that especially towards the point of you're never going to be able to fully replicate what that live looks like, but we just want to make sure you can replicate close enough that your assumptions are going to work.
You're
Yes.
breaking up a lot, Sasha. Oh, sorry. Yeah, go ahead. I think that's probably what he said.
I thought so. So one question, you mentioned in the roadmap about detection of saturation. Were you referring there to saturation of this tool or saturation of the backend that you are testing?
Yeah, actually a little bit of both. Currently, at least for the saturation of the tool itself, there are measurements within that, but there's not a loud warning that'll happen. So we would like to make at least the UX around that a little bit tighter. But you'll see that in those aggregate performance metrics that I was talking about, where it's always performance timing itself. You'll see those grow, and that'll be your signal, at least for now, towards that use case. towards the oversaturation of the server. That's kind of the core one we were looking at and thinking of, which is just that being able to early detect and shut off that benchmark if we know we're outside the bounds of what that server can handle. So, there's a little bit of confidence that goes into that. We're trying to add a statistical confidence interval and make that configurable for you to be able to turn on and use. But yeah, that's generally just if your server isn't powerful enough for the request rate that you're hitting it at, we're monitoring to see if the queue is growing, if the latency is growing and our throughput is stabilizing, and then putting some statistical guarantees on that. The final thing I would say on that is there's also another thing that we included in there, which is if we are undersaturated, we want to figure out when the proper time is to shut off that benchmark so that we have some statistical confidence that that we've measured correctly. So currently you can just set a static time or a static number of requests across all benchmarks. And we want to be able to automate that as well so that as it's running, it'll shut off automatically once it's gathered enough data.
Got it. And there was a number that you meant that was in the slides that you hit 99.9% of the time. The planned schedule, you hit those marks 99.9% of the time. I'm guessing that saturation is detected when that doesn't go according to plan. The planned schedule and the real timestamp that you get in the execution are different.
Yeah, for saturation of the load gen. Yeah, exactly.
Okay.
Right.
Okay.
Kenneth, go ahead, Michael.
Yeah, go ahead.
Sorry, my audio is back, I believe. Kenneth, go ahead, please.
Hey, so this is really useful. We have scripts for doing this during our benchmark first stage now. So I will most probably start using GuideLLM. Thanks for it. So, but I have a question. It's related to this. So, for example, one thing I am struggling with is reproducibility. So do you guys have any advice? So what I am saying is, so I am using Qwen model. So I am seeing Qwen latest version 30% different on my reruns. Let's say if I have 100 records on my reruns, 30 records produce different output. So any advice around that?
Yeah, and Michael, maybe you have some on that, at least just towards trying to stabilize. I mean, anything that you try and do to get exact reproducible outputs from the model, at least for real data, you're going to pay a penalty on performance, a huge penalty on performance generally. But even within that, just switching from different NVIDIA drivers and things like that, that will change the execution profile and therefore your outputs. So it is really, really hard to control for. The pathway we would recommend is when you're benchmarking, generally doing synthetic data is the way to control for that, because you can set the exact number of output tokens, the exact prompt tokens, and therefore measure an exact distribution. But if you're looking at quality of the answer and the quality of the answer not changing, that one's a lot harder. But at least under GuideLLM, it will send the exact same request at the exact time when you're using it to try and mimic that.
Okay, thanks. So regarding the quality part, is there any suggestion? Like what should we do ideally?
I think in general, you have to be fault tolerant to it. Michael, you look like you said you want to say something.
No, yeah, I'm it's a bit of a subjective thing based on your goals. Yeah, it's just hard to get accurate timings and behaviors.
Yeah.
So what I'm planning to do is like run evaluation on multiple runs, and average looks good for the product metrics.
Yeah.
Is there anything better than that?
That's pretty much the standard everybody does, as well as in the research community for the papers that go up. It's all just statistics and running enough data through it.
Yeah, you have like a standard error for a reason. Just be aware of that, and sample enough. Yeah.
Thanks, guys. I will for sure adopt GuideLLM. I'm just calling it up. Thank you.
Awesome.
So I had a query regarding like multimodal models. Is the vision language model kind of supported here?
Not yet. That's something we're looking to land very quickly, hopefully in the next couple of weeks, to be able to do image plus text and then audio plus text, or image alone and audio alone. The core point being that we're always still targeting generating text as the output, but we do want to be able to enable those multimodal LLMs for both audio and image.
Cool, thanks. And the second point was, do you support batch inference benchmarking too right now?
That's a great question. Not currently. We made a conscious choice to not go after batch, primarily because we were looking at that server use case. But it is something that actually is in the roadmap right now to be able to get in. And actually, that's something kind of along the same timelines. Hopefully, in the next couple weeks, maybe month and a half or so, we're looking to add in the Python vLLM implementation, and with that, be able to run batch through Python vLLM, as well as run batch through the traditional OpenAI completions backend.
Cool, thanks.
Yeah, and then last from Jadiel.
So, one last question. Sometimes users may use the same data set, same backend, different users using same data set, same backend, and same scheduling plan. So there is, they don't know each other, but there is a duplication of evaluations here. Any plans to publish some common evaluations so that, you know, if somebody goes and does it, you just have the result cached from a server and give it to them?
Yeah, absolutely. So Charles, I know, has a big website out on that that is collected for that, and then also at Red Hat we are collecting a bunch of that data as well, and hoping to publish that out just in terms of pre-established benchmarks and be able to share those out. And yeah, Charles, I don't know if there's anything you wanted to add in there.
Yeah, +1 for LLM Almanac. Check it out.
Yeah, I can show it super quick if there's time. As Sasha mentioned that at the beginning. Seems up to you.
Yeah, go ahead.
Let's do it. We're here.
Hell yeah. All right. Okay, so let me pop open my screen share here. All right, so you should be seeing my screen there. Cool. So I work at Modal. We sell time on computers. People call that serverless. And one of the things that we do is serverless GPUs. And one of the things people want to run on serverless GPUs is LLM inference, and especially using the vLLM engine. And a lot of people would come to us and be like, yo, I want to run vLLM and I want to move off the OpenAI API. How much is that going to cost and what performance can I get? And I was like, well, man, I sell computers. I don't sell tokens. It's up to you. And people didn't like that answer. And GuideLLM has helped us close that gap and produce all these sort of benchmark results so people can do capacity planning, cost planning, how do we hit our SLO, etc. So that's what we have here at this website, modal.com/LLM-almanac. That'll take you here. It's this is a very high level interface intended for people who initially are kind of just getting started with this, or want to get very quickly get this sort of order of magnitude rough sense. Am I crazy for wanting 1 ms intertoken latency or 1 second time to first token? So it's a relatively simplified interface compared to raw SQL queries over a database of GuideLLM results. But so the interface here, this is this sort of Mad Libs interface. So the way I kind of interacted with it just now was when Mark was like, oh, what's the here's a workload we're going to test with GuideLLM. So I click this button. You can't see it because of the way screen sharing works these days in Firefox, but there's a drop-down menu that's showing up on my screen. So I pick int4 Llama 318B. I want to run it with vLLM. I have some number of tokens in and out that I expect coming from my users. Maybe I think it was around 512 in and 256 out in your case. Don't have that exact workload benchmark, but we have 512 in, 512 out. Your SLOs that you suggested were on first token and intertoken latency, not time to last token. So actually the total number of output tokens don't matter as much. but you said, so we could look at each token for inter-token latency SLOs. Let's go with first token though, and you said 200 ms. Don't have that exact number, but we got 300 ms 95% of the time. So this is like kind of selecting out which benchmarking runs might hit these requirements, whether it's the model, the quantization, or the behaviors. Let me zoom out a bit so that you can actually see the whole thing. Like I can switch here between the different models here, and you can see the results down there are changing. But yeah, so for Llama 3.1 8B int 4 with vLLM, we do find that you can get 200 ms, 250 ms time to first token on our platform, including a little bit of network latency in there. And if you wanted to actually like check that out and reproduce this run, you can grab that, and you can also kind of see what are the various, at various different request rates, what kind of latencies are you seeing? That's what this chart is showing here. If for some reason you were considering running engines besides vLLM, we do have results for that. But we found Tensor TLM was just a huge pain in the ass and didn't spend the time to configure it to run, search through 70 different flags that are undocumented to try and find the one that makes it fast. We did run sglang and found the results were about the same. So mostly sticking with vLLM as we move forward. But yeah, that's the tool built on top of GuideLLM. Check it out. Let us know if we're missing anything that you're interested in. Yeah.
Sweet. Thanks a lot, Charles. And in addition to the graph and the data and everything, there's also a lot of nicely written prose and summaries and insights into how to benchmark, how to think about all these performance things, especially if you're early on your journey in benchmarking and doing performance engineering. I think this is a really good starter to get you thinking about a lot of the right things. Definitely. Yeah.
All right. Well, wow. Thank you for sticking with us for an hour and a half almost. Should we just call it quits right here, Michael, do you think?
Yeah. Appreciate everyone staying around this time. Glad people like and value benchmarking. It's important.
There are dozens of us, Michael. There are dozens of us. Yeah.
Okay. Thanks, everyone. Have a great week, and we'll see you after a break for some vacations, and then we'll continue office hours into the rest of the year.